Okay, in the last video, we were talking about prime factorization and about making factor trees in order to express a number as a product of its prime factors, like this example with the number 40. So that helps us in simplifying or reducing fractions. In this way, it says to simplify or reduce a fraction means to write the fraction in its simplest form. A fraction is completely simplified when the numerator and the denominator have no factors in common. So this method is called prime factorization method for simplifying a fraction. It works every time. We just have to remember what we just went over as far as prime factorization. So for one, we prime factor the numerator. Two, we prime factor the denominator. We write out all those factors, cancel all the factors one for one from the numerator and the denominator if you could find them, if they're found in both numerator and denominator, and then multiply out the remaining factors to get the simplified fraction. So let's put this into action. And we have two examples here. And our first one is 24 over 42. Yeah, why not? Let me switch to this orange pen. So 24 over 42. Our numbers are 24 and 42. What we can do is, let's make some little factor trees. So like 24. So 24 is, one way to factor that is 4 times 6. And then the 4, we can then split up, we can factor as 2 times 2. 6 factors as 2 times 3. So our prime factorization, let me highlight, for 24 is 2 times 2 times 2 times 3. So let me say this equals, on top we can do 2 times 2 times 2 times 3. And let's make a fraction bar. And then let's do the same thing for the number 42. And let me make my little tree, I guess, closer over here. So let's do 42. And what is that? That is 6 times 7, right? Now 7 itself is actually prime. But in 6, like we just factored 6 over here, 6 you can factor as 2 times 3. So your prime factors for 42 are 2 times 3 times 7. And we'll write it out. 2 times 3 times 7. Okay, now we can, whatever we have in common on both top and bottom of the fraction, we can cancel out in pairs. So like we have a 2 on top, we have a 2 on bottom. Okay. Now we don't have any more 2's on the bottom, so we can't cross out these 2's. But we do have a 3 on the top and on the bottom, so we're going to cancel and cancel. And then on top now we have 2 times 2, and on the bottom we have 7. Nothing else cancels, nothing else can be found in both the numerator and the denominator. So we can multiply what we have left over, 2 times 2 to get 4. And on the bottom we have 7 times, it's actually just 7 times 1, because when we cancel everything out here, it's really, we have a 1 remaining. So 4 over 7, 4/7. That's in lowest terms, that is a reduced or a simplified fraction. Okay, we can do the same thing over here for this example, negative 28 over 7. So, and let me switch to a blue, I guess. Let's see, this is blue. So 28. So 28 is actually 4 times 7. But to actually, if we want to be consistent here, to do the prime factorization, it's not 4 times 7, but it's 2 times 2 times 7, because 4 is 2 times 2. So just to make sure we know when we do prime factorization, it is 2 times 2 times 7, the very ends of our tree. Excuse me. And this is actually a negative, so our answer is going to be a negative. Something interesting happens with this problem. We write the numerator as 2 times 2 times 7. The denominator is just 7. So we cancel what's in common, 7, 7 and 7, and what we have left over is just 2 times 2 on the top. And it's a negative, so we'll go ahead and write this as it's negative 4 over 1. Because again, when we cancel everything in the denominator, it becomes a 1. And then one of our properties of fractions is that when we have anything over 1, it is the same number. It's a whole number. It's an integer. So we have negative 4 as our answer. But it's a good time for me to remind everybody something that I like to say a lot, because it's the truth, is that a fraction is a division problem. So this is really saying, instead of saying reduce this fraction, it's really saying what's negative 28 divided by 7. Or really, negative 28 divided by positive 7. We end up getting a negative 4. Remember that from our properties of fractions, how we deal with negatives when we deal with fractions. But again, it's just a division problem. We were just dividing 28 by 7 and get 4. But we can do it this way using prime factorization to kind of see it in a different way. And then speaking of things in a different way, simplifying fractions by powers of 10. This gets very simple as well, because our example here is 120 over 160. We want to simplify it or reduce it to lowest terms. What we can do is, because they both end in 0, we can think about it, this is saying 12 times 10 over 16 times 10, and then get rid of the 10s. But a shortcut there, as you can see, is because they both end with a 0, we can just take our original problem, instead of having to write it out like this, and just cross out the zeros. Just strike them out, because we have 120 on top, 160 on the bottom. So it reduces to 12 over 16. Now we're not done, because 12 and 16, this is now our new problem. We continue to factor it. We'll start off by crossing out the zeros, or getting rid of those factors of 10. And the same thing works for 100 if you have 2 zeros in a row. So that's why it says powers of 10, not just 10. But so let's again do the same thing we were doing. So let's do 12, and we'll do prime factors. So 12 is what? 3 times 4. 4 is 2 times 2. So 12 is 3 times 2 times 2. And then 16 is 4 times 4. It's a perfect square. And if we factor the 4s, we end up getting 2 times 2 for both. It's funny because 4, if I bring back those good terminology, 4 is also a perfect square. So 16 is actually a perfect square, and it's also a perfect power of 2. It's really 2 raised to the 4th power. So again, just to go back over that, if we want to represent these using prime factors, 12 we can write as 2 squared times 3. That's 2 times 2 times 3. And then 16 we can write as 2 times 2 times 2 times 2, or 2 to the 4th power. So putting this into practice, let's go back to blue. 12 is, again, 2 times 2 times 3. On the bottom we had 16, which was 2 times 2 times 2 times 2. Cancel the common factors. So we have a pair of 2's we can get rid of. We have another pair of 2's we can get rid of. So our numerator, we only have a 3 left. In the denominator, we have 2 times 2, which is 4. So simplified fraction, or reduced fraction, is 3/4. Okay, fractions that are different, made up of different numbers, but represent the same value, are called equivalent fractions. This is equivalent. And then you can see visually some examples here. We have 1/2. This is, I guess, a picture of a pizza. We have 1/2 of the pizza, but you can also say we have 2/4. If you split this into fourths and you get 2 of those fourths, it's visually, you can see by the picture, it's the same exact quantity. 2/4 is the same as 1/2. And then if you have 8 slices of pizza and you grab 4 of them, then you grab half of the pizza. So again, 1/2, 2/4, 4/8 are equivalent fractions. They're equal. They represent the same amount. Any fraction that can be simplified to lowest terms, if you simplify it, it's equivalent to the original fraction. So an example is 54 over 90. What we've done here is we did prime factors for 54, prime factors for 90, crossed out the common factors, and reduced it to 3/5. So 54 over 90 and 3/5 are equivalent fractions. They have the same value. They are equal. Instead of having to do that, there's a quick way to determine whether or not two fractions are equal. And that's by using something called cross products. So if the idea in math is if A over B equals C over D, that's true if we can multiply A times D, so the numerator of the first times the denominator of the second, and get the same number as if we multiplied the denominator of the first times the numerator of the second. So it says determine if the following fractions are equivalent. So let's do cross products here, multiply across. So here we have 18 times 5, and let me write this all out. 18 times 5. Okay, if we multiply that, let's say 18 times 5, so it's the same as 9 times 10, so it's 90. And then let me do here in blue, if we multiply 45 times 2, you also end up getting 90. So because these two products are equal, 90 equals 90, then you can say, yes, these two fractions are equivalent. 18 over 45 is the same as 2 over 5. All right, and we'll just do the same thing again. We'll do here, we'll multiply across. We'll multiply across 7 times 15. So 7 times 15 is what? It's 105. And then this denominator down here and this numerator up here, 8 times 12, ends up giving us 96. So because these are not equal, they're not the same value, these are not equivalent fractions. So 7/8 is not the same value as 12 over 15.